Welcome to this lesson on load balancers. Let's get started. I'll start the discussion with whiteboarding. First of all, we will understand what a load balancer is. Say, for example, this is a client, and in the middle, there is an entity which is load balancer, and then there are different servers. Client will send the request. So you can think of it like one entry point, and then load balancer sits in between, and it is going to distribute the traffic to multiple backends. So that means here there are multiple servers or multiple backends. It load balances or distributes the incoming traffic to multiple backends. Now, what is the benefit associated with the load balancer? The first benefit is scaling. At any point of time, you can increase the number of servers. Let's say there were 3 servers, I made it 4. So you can increase the number of backend servers. So that flexibility is there in case of load balancing. The second benefit is resource utilization. So this load balancer, it is going to distribute the traffic to different backends based on load balancing policies. So it will ensure that these resources are properly utilized. So this is also one of the benefits. And the third benefit that I can think of is load balancer ensures that you get high availability. Why? Because you see there are multiple backends, multiple servers behind a load balancer. Even if one of the server becomes unhealthy, then load balancer is going to continue distributing the traffic to other servers. And that is how it ensures high availability. So now let's discuss about the types of load balancers. And we have separate lessons coming up on these types. But just to quickly explain you, there are 2 types of load balancers. The first one is public load balancer, and then we have private load balancers. As the name suggests, public load balancer is going to have a public IP, and it will be reachable from the internet. Private load balancer will have private IP, and this IP address that will be from the hosting subnet, the subnet inside which this private load balancer is going to reside. And then it is only visible from within the virtual cloud network. Now let's talk about the load balancer concepts. There are a total of 9 concepts, and I will discuss it one by one. The first concept is that of backend servers. So what is a backend server? At the very start, I mentioned that load balancer distributes the incoming traffic to multiple servers that are placed in the backend. So backend server basically means that these are the servers that will generate the content. For example, this is your load balancer. This is the incoming traffic. So it can be TCP or it can be HTTP traffic. So this is the incoming traffic, and then the load balancer is going to forward it to or distribute it to the backend server. So ultimately, this backend server is responsible for generating content. Now the second component is backend set. Backend set is nothing. It's a logical entity, and you can think of it like a list of backend servers. For example, backend server 1, backend server 2, and along with the backend server, the health check policy as well as the load balancing policy. We are going to look at both these terms are also included. That means the backend set is defined by the list of backend servers plus the health check policy plus the load balancing policy. So this is what is your backend set. Now let's talk about health check policy. So the third construct is health check policy. Now what is this health check policy? This is simply a test. And what's the test all about? As I mentioned, we have the load balancer, we have the incoming request, then the load balancer is going to distribute it to different backends. Let's take the example of this backend server 1. Now this test is going to confirm whether this backend server is available. So if the backend server fails, then the load balancer is going to take this server out of rotation. And there are two ways in which you can conduct the health check. The first is you can conduct it at a TCP level, and the second is HTTP level. In case of TCP level, it is going to be a connection attempt, and in case of HTTP level, it is going to be a request. In case of HTTP level, the request is going to be sent at a specific URI, and then the response will be validated. But the primary purpose of health check is to confirm or is to determine whether the backend servers are available and healthy. Now the fourth concept is regarding listener. As the name suggests, listener means it is going to check for incoming traffic on load balancer's IP address. And to configure a listener, what is the information that we provide? We provide protocol and port number, HTTP, HTTP2, HTTPS, and TCP. So listener checks for incoming traffic on the load balancer's IP address. And in case you are handling these traffic types, you need to configure at least one listener per traffic type. All right, so this marks the end of the first part of load balancers. We'll continue the discussion in the next lesson. Thanks for watching. Welcome once again. Let's continue the discussion. Now let's talk about the fifth concept, which is load balancing policy. Let's say this is incoming traffic. The load balancer sits here, and then these are the backend servers. Now this load balancing policy, it is going to tell the load balancer how to distribute traffic. So how to distribute traffic amongst the backend servers. And there are three such policies. The first one is round robin. What happens in round robin? The incoming traffic is sent sequentially to each server, and this is the default policy. So incoming traffic will be distributed sequentially to each server. The second policy is least connection. Now this policy will enable load balancer to send the traffic to the backend server. Let's say backend 1 has the fewest active connections, hence load balancer will send the traffic to backend 1. So this least connection policy will send the traffic to the backend server with fewest active connections, and therefore the name says least connection. The third policy is IP hash. Now in this IP hash, the incoming IP, which is nothing but the source, is going to be used as a hashing key. So what typically is going to happen is, using this policy, the load balancer service will route the non-sticky traffic to the same backend server. So if a request is originating from a particular IP address, and if we have selected IP hash, then the non-sticky traffic is going to be sent to the same backend server. Now, one thing to note here is that this load balancing policy will apply differently to TCP load balancers, to sticky sessions, to sticky HTTP, and non-sticky HTTP. So these are the 3 load balancing policy types. Now the 6th concept is regarding the shape of the load balancer. So in OCI, the load balancers, they use flexible shape. Now what does it mean? It means you have to specify 2 things. First, you have to specify the minimum value, and secondly, you have to specify the maximum value. Now what's the value here? Value is basically the load balancer's bandwidth. And what is the significance of having this minimum value? It specifies instant readiness for the load. And what is the significance of maximum value? Using this, we can have a control on the cost. And in case of OCI, you can specify from 10 Mbps to 8000 Mbps. So this is the range. For example, you can specify minimum value as 10 Mbps, and you can specify maximum value as, let's say, 3000 Mbps, just as an example. Then the 7th concept is on SSL. So there is a client, and then there is a server. By SSL, we mean that it's basically an encrypted link. And in OCI, there is support for SSL termination. What happens in case of SSL termination? This is the client, this is the load balancer, and this is the backend. Now this traffic is going to be SSL traffic, but this traffic is going to be unencrypted. Therefore, the name says SSL termination. The communication between client and load balancer is encrypted, and then the load balancer is going to decrypt it and send it to the backend instances. So this is what is your SSL termination. Then there is a concept of point-to-point SSL. In this case, if we redraw it, the SSL is terminated at load balancer. So this is encrypted. This is also encrypted, but here the SSL is going to terminate, and then the load balancer is going to reinitiate an SSL to backend, and therefore we call it point-to-point SSL. So both these will be encrypted, unlike SSL termination where this portion is unencrypted, the communication between the load balancer and the backend instances. The third option is SSL tunneling. So in this scenario, the load balancer is going to tunnel incoming SSL to the backend server or application server. So these are the three different options when it comes to SSL. Now I will discuss the eighth concept, which is session persistence. Now, what is the meaning of session persistence? Let's say there is a client and this client has sent a request. So there is the load balancer and there are different backend servers. Now, by session persistence, we mean that all the requests that are originating from a client will be sent to a single backend server. And can you think of any use case? So there are scenarios like shopping cart and login sessions where we need this kind of session persistence. And there are two ways in which we can enable session persistence. So the first method is application cookie stickiness, and the second option is load balancer cookie stickiness. So we'll not go into these details, but I just wanted to explain you at a pretty high level what is the meaning of session persistence. So in a nutshell, all the requests originating from a client are going to be sent to a single backend server. Now the ninth concept is with respect to certificates. So while creating a listener, if you are using HTTPS, then you need to associate a SSL server certificate with the load balancer. And using this certificate, the load balancer is going to terminate the connection and decrypt the request. Now, one final thing before we move on to the deck. There are two things that I'm going to talk about. The first is path-based routing. And secondly, we have host-based routing. And all these can be configured using routing policies in load balancer. So what happens in path-based routing? Let's say this is the incoming traffic. Let's say it is www.abc.com. So this is the load balancer. Now you want that if the path is, let's say, abc.com/app, it should go to this particular backend pool. If the path is, let's say, videos, it should go to this particular backend pool. Similarly, if it is /images, it should go to a different backend pool. So this kind of setup is what is known as a path-based routing. You see here, this is the path. Now, in case of host-based routing, again, you assume this is the incoming traffic. There is this load balancer. In this case, it is going to be two different hosts. For example, abc.example.com and xyz.example.com. This request is going to be sent to a different backend pool, and this request is going to be sent to a different backend pool. So this is what is your host-based routing. So with this, we conclude this discussion on whiteboarding for load balancers. Thanks for watching. All right, now let's look at the deck and reinforce the concepts that we have learned in the whiteboarding. What is an OCI load balancer? As you can see in this slide, the load balancer sits between the clients and the backend servers. And we also looked at the advantages of using load balancer in terms of resource utilization, scaling, and fault tolerance, as well as high availability. So the request that will come from the clients, the load balancer is responsible for distributing that request or distributing the traffic amongst the backend instances. There are two types of load balancers. I already mentioned that there is a public load balancer and then there is a private load balancer. In terms of protocol, it supports layer 4 as well as layer 7. So you see HTTP, HTTPS, HTTP2 and TCP. We also discussed in the whiteboarding some of the advanced features of load balancers. For example, session persistence and path-based routing. We also talked about the three different types: SSL termination, point-to-point SSL, and SSL tunneling. So load balancer supports all these configurations. Now let's look at load balancer concepts. We have discussed all of these. What's a backend server? When do you need a certificate? What are the different types of load balancing policies? How does a load balancer shape look like? Why do we need health checks? What is the significance of a backend set? What exactly is a listener? What do you mean by session persistence and SSL termination options? So now if we look at the load balancer shapes, this is the option that you see. You have to choose the minimum bandwidth and the maximum bandwidth. And the option that is available to you is from 10 to 8000 Mbps. So just specify the minimum and maximum bandwidth. And therefore we call it flexible shape. Now previously there used to be a dynamic shape when it comes to load balancer, but now OCI does not allow you to create a dynamic shape. So you have to go with flexible shape. So just define minimum and maximum. And I also mentioned what is the significance of each of these options. For example, minimum bandwidth, it is going to provide readiness for the load because that is the minimum bandwidth that you have configured. And the maximum allows you to have a control on the cost. I also discussed two different architectures, host-based and path-based routing. So in this architecture, you see that this is the load balancer that we have deployed, and this is deployed in a public subnet. So these are the two different backend sets. We can have a scenario where if you are requesting for host1.domain1.com, the load balancer is going to send it to this particular backend pool. And if host2.domain2.com is requested, you can send it to this backend set too. And therefore we are calling it host-based routing or content-based routing. So multiple websites can be deployed or can be load balanced using a single load balancer. There is a concept of path-based routing. So here you see that if you need /app, this is the path. If this is the path, send it to backend set 1. If this is the path, send it to backend set 2. So this is what is known as path-based routing. So in a way, you are optimizing resource utilization by leveraging this path-based routing. So this marks the end of this lesson on load balancers. Thanks for watching. Welcome to this lesson on load balancer policies. Let's get started. So in OCI, there are three types of load balancer policies. The first is round robin, which is also the default. The second is least connections. And the third is IP hash. So there are three different load balancing policies. You also have an option to assign a weight to the backend server. These load balancing policies that I mentioned, round robin, list connections, and IP hash, they apply differently to TCP load balancer, HTTP request in case it is sticky, and HTTP request in case it is non-sticky. So the load balancing policy is going to be applied differently to these three different scenarios. In case of TCP load balancer, whatever policy that you have defined and whatever wait criteria that you have defined, that will be used to direct an initial incoming request. Let's say this is backend 1, this is backend 2, and this is backend 3. In case of TCP load balancer, it is going to consider the policy and the wait criteria that we have defined to direct an initial incoming request. So let's say this is the first time the request is coming in. So the policy that we have defined and the wait criteria that we have defined, based on that, it is going to send that request, let's say, to backend server 1. So what happens in this case is the subsequent packets on the connection are going to be sent to the same endpoint. Now let's look at what happens in case of HTTP request, which is sticky. In this case, it is going to forward the request to the backend server that is specified by the cookies session information. And in case of HTTP request, which is non-sticky, the policy and wait considerations or the policy or wait criteria is going to be applied to every incoming request. So this is the difference. In this case, what can happen is, let's say this is the client and it's sending the request 1. It can go to the backend server 1 and request 2 can go to backend server 2. So this is what happens in case of a non-sticky HTTP request. And just to very quickly iterate, although we have discussed this, in case of round robin, the incoming traffic is going to be sequentially distributed to each server. In case of least connection, the traffic is going to be sent to the backend server with fewest active connection. And in case of IP hash, it is going to use the incoming IP as the hashing key, and then it is going to send it to the backend server. Remember, in case of this IP hash, only the non-sticky traffic is going to be sent to the same backend server. Now let's go to the deck and reinforce what we have learned. So load balancing policies, primarily they are of three types: round robin, least connections, and IP hash. Using load balancing policies, you can tell load balancer how to distribute a traffic to backend servers. So let's first look at round robin. This is the default load balancer policy. And I already mentioned that the incoming traffic is going to be distributed sequentially to each server. That's there in the backend set list. And there are some use cases when this round robin load balancing policy is used. It works best when the backend servers have similar capacity because the incoming traffic is going to be sequentially sent to each server. So let's say the capacity is different in terms of virtual hardware configuration. Because in case of round robin, the traffic is going to be sequentially sent to these servers, let's say first, second, third, and then fourth, fifth, sixth. Now, if a server has a better virtual hardware configuration than the other, so it doesn't make a lot of sense to go with round robin load balancing policy. And then the second use case is when the load that is required by each request. Ultimately, the request has to be processed by the backend servers. So if the load that is required by each request, it does not vary significantly. For example, let's say there is a processing task. Let's say one of the servers is taking 50 seconds to get it completed. Then there is another request sent to another server, another backend, and that gets completed in 10 seconds. So this is an example of processing load required by each request. In case they vary significantly, then round robin is not a choice. In case they don't vary significantly, then you can go with round robin load balancing policy. Then we have least connections. So in case of least connections, the load balancer is going to send the traffic to the backend server with fewest active connection. So in a way, you are kind of balancing the distribution of active connections. And as I mentioned, you can also assign a weight to each backend server. So you can make it weighted. Then IP hash, in this case, the incoming IP is going to be used as a hashing key, and based on that, the request is going to be sent to the backend server. So in a way, it is sending the non-sticky traffic to the same backend server because we are using the incoming IP as a hashing key. So the request from the same client will go to the same backend server every time as long as it is the same incoming IP. And at the very start of the whiteboarding discussion, I mentioned that the load balancing policy decisions will apply differently in case it is a TCP load balancer or it is a HTTP request, which is sticky, and then non-sticky HTTP requests. And we have discussed that in case of TCP load balancer, the first time the load balancer is going to consider the policy and the weight criteria, and then the subsequent packets on the connection is going to be forwarded to the same endpoint. In case of sticky request, it will forward the request to the backend server based on the cookies session information. And in case of non-sticky HTTP requests, it is going to consider both the policy and the weight criteria. And in this case, the incoming request can be sent to different servers on different times. So this marks the end of this lesson. Thanks for watching. Welcome to this lesson on load balancer health checks. Let's get started. So in the load balancer lesson, we have discussed that if this is the load balancer and this is an incoming request, so this is incoming traffic, and then there are different backend servers. Let's say backend 1, backend 2, and backend 3. Now let's say this BE1 or backend server 1, it fails. Now how do you ensure that the load balancer does not send traffic to this particular server? So for that, we have something that is known as health check. In layman terms, we also undergo health checks, right? And if we are ill or we are not healthy, we don't go to the office or we take leave from work. So when we are unhealthy, our manager is not going to assign workload to us. In the same way, if this backend server is unhealthy, the load balancer will stop sending traffic to this particular server. So the load balancer is going to take the server temporarily out of rotation. But what's the process behind it? The process is creating the health check. So creating the health check confirms whether these backend servers are available. And there are two ways in which you can configure this health check. So you can create a request or you can create a connection attempt. So this is basically your TCP level. This is basically HTTP level. So now let's go to the deck and continue the discussion. So health check basically confirms whether the backend servers are healthy or not. It is going to continuously monitor the backend server. And I mentioned that there are two ways in which you can do it. You can do it at a TCP level or HTTP level. So you have two choices. You can either go for request or you can go for connection attempt, and ensure that you are selecting the health check protocol so that it matches the service or the application. Now, when you create the health check, it is configured and activated for backend set, and the overall load balancer. So this is how the screenshot looks like when you are creating a health check. So here you see that this is where you can specify the protocol and you can provide HTTP or you can provide TCP. Then the next option is interval in milliseconds. So this basically specifies how frequently you are running the health check, and usually the default is 10 seconds. So this is 10,000 milliseconds or 10 seconds. So that is the default. How frequently you want to run the health check. Then this timeout in milliseconds, it specifies the maximum time to wait for a reply to a health check. So let's say this is the load balancer. This is the backend server. So you are sending a request and then there is going to be a response. So this timeout specifies the maximum time to wait for a reply to the health check. And in case if the reply returns within the timeout period, then the health check is successful. The next option is number of retries. So as I explained you, this was one try. So I can specify the number of retries to attempt before a backend server is considered unhealthy. And this number also applies when recovering a server to the healthy state, and the default value is 3. That means we are conducting a health check. We didn't receive any response within 3 seconds. So that is what is configured here. 3000 milliseconds means 3 seconds. So first time we did not receive any response. So it's 1. Similarly, when it will be thrice, then the backend server will be marked unhealthy. So this marks the end of this lesson. Thanks for watching. Welcome to this lesson on public load balancers. Let's get started. So the very first thing that I would do, I will create. So let's say this is OCI region. In this example, we are assuming that it's a multi-AD region. That means there are 3 availability domains. So this is AD1, availability domain 2, and availability domain 3. Now, when you create a VCN, we know that the VCN spans across multiple availability domains. So this is the VCN that we have created. In OCI, we know that when we are creating a subnet, we can have 2 types of subnet. The first is AD specific subnet. So subnet 1, subnet 2, subnet 3, and then we can also create a subnet which is known as a regional subnet. That means it spans across multiple availability domains. So we can also create a subnet like this. So this is your subnet 4. Subnet 1, subnet 2, and subnet 3, these are AD specific subnets. And subnet 4 is a regional subnet. Now there is a reason why I am explaining you this. So the public load balancer, first of all, will always sit inside, or you can create a public load balancer in a public subnet. You cannot create a public load balancer in a private subnet. And when a load balancer is created in a public subnet, that load balancer is going to have a public IP address. And because it has the public IP address, so it can directly receive the traffic from internet. The scope of a public load balancer is region. A public load balancer either requires a regional subnet. In our case, S4 is the regional subnet. And if the regional subnet is not available, then it requires two availability domain specific subnets. For example, S1 and S2. So that's the requirement. In case it is a regional subnet, just like S4, the load balancer service is going to create a primary load balancer and a standby load balancer. So this is the standby, each in a different availability domain. Now, why this is so? Because even if there is an outage in availability domain, you will be able to access the load balancer. Now, in case you create the load balancer in two AD specific subnets, in this case, one of them will have the primary, the other one will have the standby. Now, if the primary load balancer fails, then the public IP that I mentioned, it switches to the secondary load balancer. Technically, the load balancer service treats these two load balancers, be it primary or secondary, as equivalent. So you basically cannot specify which one is primary. Now, this was regarding the placement of the load balancers. Now, what about the private IP requirement? Whenever you provision a load balancer, it requires one private IP address from its host subnet. It also requires public IP address. So you see that because there is a primary and there is a standby load balancer, each will require one private IP address from the host subnet, apart from the public IP address that I mentioned. All right, let's now go to the deck and look at public load balancers. So because public load balancer is deployed in a public subnet, therefore it's going to have a public IP address. And what it also means is that because it is reachable from the internet, it is going to accept the traffic from the internet. The scope of public load balancer is regional, and if there is a multi-AD region, then the load balancer requires a regional subnet, and if the regional subnet is not available, then it will require two availability domain specific subnets. We have discussed this in the whiteboarding. So think of it like a primary load balancer and a secondary or standby load balancer. But technically, there is no difference between these load balancers. And you also cannot specify which load balancer is primary and which one is the standby load balancer. So the benefit associated with this model is that even if there is a failure of an availability domain in a multi-AD region, still you will have the load balancer service up and running. As I mentioned, the load balancer service is going to attach a floating public IP to the primary load balancer, and in case of failover, that IP switches to the secondary or standby load balancer. And there is nothing called primary and secondary. That's just from an explanation standpoint. You cannot specify which one is primary and which one is the standby, because from a service standpoint, both the load balancers are equivalent. So now let's look at the architecture diagram when it comes to public load balancer in case of regional subnets. So now here you see that there is a VCN and it spans all the availability domains. So we have deployed the public load balancer in the public subnet. And because this is a regional subnet, what OCI does is it places the primary load balancer in one availability domain and it places the standby load balancer in the other availability domain. And you can also see there is a public IP address associated with it. In case there is no outage in either of the availability domains, so you see that all the traffic would get distributed from the active load balancer or primary load balancer. Now, in case there is an outage of availability domain 1, then the traffic will get distributed to the backend servers from the failover load balancer or the standby load balancer. So this was the case of a regional subnet. In case of availability domain specific subnets, you see that the service provisions active load balancer or the primary load balancer in one AD and the secondary or standby load balancer in another availability domain. So that's basically the load balancer pair. And then the same thing. If there is no outage, then all the traffic will be sent to the backend servers from the primary load balancer. And in case there is a failover, then it would be sent using the standby load balancer. Thanks for watching. Welcome to this demonstration on public load balancer. Let's get started. I will take you to the OCI console and you can see that currently I have 3 instances running. So I will be using the first 2 instances in this demonstration. So these instances, they are running in private subnet inside a VCN. So you can see private instance 1 has this particular private IP and private instance 2 has this particular private IP address. And this instance 1, it is deployed in AD1 and private instance 2, this is in AD2. So these instances, they are running in 2 different availability domains. Now let me take you to the load balancer service. So I'll click on networking. I'll click on load balancers. So here you see that there are 2 options, load balancer and network load balancer. So we'll click on load balancer, click on create load balancer. So I am okay with this name. The visibility is public because we are creating a public load balancer. So in case of public load balancer, it will be assigned a public IP address that will be reachable over the internet. I am okay with ephemeral IP address. So this is the place where you will select the bandwidth. So I am okay with the default, minimum 10, maximum 10. I'll select the virtual cloud network. There are 2 subnets here. One is public, the other one is private. But as I am creating a public load balancer, it is showing me only the option for public subnet, which is regional. Let me also show you the advanced options. This is with respect to security. You can associate a web application firewall policy. This is with respect to acceleration. You can use a web application acceleration policy to speed up your performance. And this is again with respect to management and tagging. So I will hide advanced options. Click on next. This is where you will choose the backends. So you need to specify a load balancing policy. Let me select weighted round robin and select the backend servers. So remember, I am creating a public load balancer. The load balancer will be deployed in the public subnet, but my instances, these are running in the private subnet. So these are the backend servers, private instance 1 and private instance 2. So I'll click on add selected backends. This is where I will configure my health check policy. So I'm okay with HTTP, port 80 and all these settings. So under advanced options, you can give your backend set a name and then security list. I have selected the option automatically add security list rules. And this is the place where you provide information with respect to session persistence. And as I mentioned in the lesson, there are 2 types of session persistence, application cookie persistence and load balancer cookie persistence. So I'll hide the advanced options. I also have an option to use SSL. I need to configure the listener settings and the type of traffic that the listener will be able to handle. So I'm okay with this name. I'll select HTTP, port 80. I'll click on next. I can just disable it, error logs and access logs. I'll click on submit. So my load balancer is currently creating, and you can see the overall health is pending. The backend sets health is also pending. All right. So now you can see that the load balancer is active. The overall health is okay, and the backend sets health is also okay. So this is the public IP address that is associated with this load balancer. So if I just copy this and try to open this, you can see that it is taking you to instance 2. If I refresh it, it is taking me to instance 1. Again refresh, you see. So this means that my load balancer is correctly configured, and because I have specified round robin load balancing policy, it is sending the request to instance 1 and instance 2, you see. All right. So now let me return to the load balancer, and under resources, you can see this is the backend set. The number of backends is 2. And if you go to the backend set, click on backends, and this is where you can see the weight and the health status. All right. So if I return back to the load balancer details, you can also see that there is option to configure path route set. Oracle doesn't recommend you use it. Instead, you have to use the routing policies, right? So routing policy, this is the backend set. This is the listener. The listener is listening on port 80. The protocol is HTTP. All right, so this marks the end of this demonstration on public load balancers. Thanks for your time. Welcome to this lesson on private load balancers. Let's get started. So when do you use private load balancers? Let's say you want to isolate your load balancer from the internet so that you improve your security posture. So that is the time when you use a private load balancer. And when you create a private load balancer, because it is created in a private subnet, it will be assigned a private IP address. And that private IP address is going to serve as the entry point for the incoming traffic. Now, unlike public load balancer, private load balancer requires only one subnet to host both the primary and standby load balancers. Because it is a private load balancer, it is isolated from the internet, so it will be accessible only from within the virtual cloud network that contains the host subnet. In public load balancer, we discussed that there is a concept of floating public IP address. But in this case, in case of private load balancer, there will be floating private IP address. So what does it mean? It means in terms of IP address requirement, a private load balancer created in a single subnet is going to consume 3 private IP address from the host subnet. One for the primary, the other one for the standby, and one for the floating private IP address. The primary and standby will require an extra private IP address that will act as the floating private IP address. So a total of 3 private IP addresses. This marks the end of this lesson on private load balancers. Thanks for watching. Welcome to this demonstration on private load balancer. Let's get started. I'll take you to the OCI console where you can see that there are 3 instances running. So for our private load balancer demonstration, I will be using the first 2 instances, and later I will perform the testing using the test instance. So as you can see, both these private instances are inside the private subnet. So all they have is a private IP address. They don't have any public IP address associated with them. But this test instance, it has both public IP and private IP. So let me go ahead and create a private load balancer. So I'll click on the navigation menu. Click on networking. Click on load balancers. So I'll click on load balancer, click on create load balancer. Okay with this name. Now here under visibility type, I will select private. I'm okay with the bandwidth options. Select the VCN. This time select private subnet. Click on next. The load balancing policy is going to be weighted round robin. I will add the backends, private instance 1 and private instance 2. The health check policy, I will keep the default. Click on next. So provider listener name and select HTTP. Click on next. You can disable the error logs. Click on submit. So as you can see, the load balancer is currently creating. Alright, so my private load balancer is now active and you can see the overall health as okay. And the backend sets health also as okay. So this time it's a private IP address. So if I try to copy it and open it in the browser, it's not going to work because it is private IP address. And if I go to the backend sets, both the backends are up and running. So let's perform the testing now. So this is the private IP address. I will return back to the instances where I have a test instance that is running. So I'll copy the public IP address. And now I will SSH inside this test instance. So this is the instance that is running in a public subnet inside the same VCN. So I will connect to this instance. Okay, so now it's connected. Now let me grab the private IP address of the load balancer. So let's now perform the testing. Okay, you see it's giving instance 2, instance 1, instance 2, instance 1. So this basically means that my private load balancer that I have provisioned is correctly configured. So this marks the end of this demonstration on private load balancers. Thanks for your time. Welcome to this lesson on network load balancer. Let's get started. So what is a network load balancer? First of all, it's a load balancing solution that operates at the connection level, which means it's a layer 3, layer 4 load balancer. One of the key characteristics of network load balancer is that it preserves the source and destination IP addresses and port. Network load balancer provides high throughput while maintaining ultra low latency, and that is why it is designed to handle volatile traffic patterns. So it offers high throughput while maintaining ultra low latency because it operates at connection level. And you don't need to configure the bandwidth because network load balancer by design is elastically scalable. That means it is going to scale down and scale up based on client traffic. And because it provides high throughput, it is an ideal load balancing solution for latency sensitive workloads. So there are 3 load balancing policies in network load balancer. The first is the default, which is the 5 tuple hash, which means it is going to route the incoming traffic based on 5 tuple. And what are those 5 tuple? Source IP, source port, destination IP, destination port, and protocol. The second option is 3 tuple hash, which includes the hash of source IP, destination IP, and protocol. And then there is also a 2 tuple hash, which basically means it's the hash of source IP and destination IP. So this marks the end of this lesson on network load balancer. Thanks for your time. Welcome to this demonstration on network load balancer. Let's get started. I'll take you to the OCI console. So I have created two instances, instance A and instance B, and you can see that both these instances have only private IP address, so they don't have any public IP address associated with them. Now I will create a network load balancer. So click on navigation menu, networking. Under load balancers, click on network load balancer. Click create network load balancer. I'm okay with this name. Okay with the visibility type as public. I am fine with ephemeral IPv4 address. I'll select the virtual cloud network. And this time I'm going to select the public subnet. Click on next. Now I have to configure the listener. So I'll select TCP as the type of traffic and I will specify the port as 22. Next. So here I have to select the backends. So I'll click on add backends. I already have both the instances running, so I will select both of them. I'll select instance B and port is 22. I'll click on add backends. The protocol is TCP and the port is 22 for the health check policy. Click next. Click create network load balancer. Alright, so my network load balancer is now active and you can see the overall health as okay. And if I scroll down under resources, click on backend sets. Click on backend set. You see that there are two backends, both are healthy. So what I'm going to do now is I'll go back to the network load balancer. I'll just grab the public IP address and we'll try to perform an SSH to this IP address, which is the public IP address of the network load balancer. So this is my IP address and I have already specified the private key file. So you see it's there. Click on open and you see that it's asking for login as OPC. And currently you see that it's connected to instance B. So let me try to connect to this one more time. And this time you see it is asking the login. I type OPC and you see that currently this has connected me to instance A. All right, so you can see that these are the two instances that are running. And if I just type hostname, this is the instance A. You see, this is the hostname. So what this typically means is I have a public network load balancer deployed, which has a public IP address, and I am trying to SSH to this public IP address, but it's actually connecting me to these backend instances that I have. We saw that we were successfully able to perform an SSH to the instances using the network load balancer. So this marks the end of this demonstration. Thanks for your time. Welcome to this lesson on web application acceleration overview. Let's get started. So let me first talk about what is web application acceleration. So this is basically a service that can speed up traffic on layer 7 load balancer. And how is it going to speed up the traffic on the load balancer? Using caching. So this is number one. And number two is compression. So by applying caching and compression, web application acceleration can speed up traffic on layer 7 load balancer. So how do you work with web application acceleration? First of all, you create a web application acceleration policy. While creating the policy, you define whether it should include caching or both caching and compression. So you have two choices. You can go for caching and you can go for caching and compression. So is creating web application acceleration policy enough? The answer is no. After you create the web application acceleration policy, you also need to create a separate acceleration resource for the load balancer. So what it means is you have this policy. In order for you to associate it or bind it to a specific load balancer, you need to create acceleration resource. So after creating a web application acceleration policy, you need to attach it to a load balancer, or you need to bind the policy to a specific load balancer, and that is what is your acceleration resource. Now, one thing to understand here is, let's say you have 3 load balancers and you have, let's suppose, one policy. You can have one policy and you can bind the policy to each of these load balancers, provided you create a separate acceleration resource for each load balancer. So this is something that we need to understand. But primarily, the purpose of a web application acceleration is to speed up the traffic on your layer 7 HTTP load balancer. And as discussed, you can apply a combination of caching and compression. So let's quickly go to the deck and talk more about web application acceleration. Okay, so here you see that we have an application hosting tenancy, and then we have remote users who can either be your users from on-premise environment or internet users. Now, both these types of users, they are trying to access the application via the layer 7 load balancer. What you also see here is that we have enabled web application acceleration on top of the layer 7 load balancer. So what is the anticipated outcome? We would like to speed up traffic on this load balancer and basically improve the customer experience. And we would also like to reduce the application latency and the load on the backend app servers. So how can we achieve these anticipated outcomes? So scenario 1 talks about improving application performance and decreasing the server load. So that can happen when we are leveraging web application acceleration caching. And the second scenario is we also would like to decrease the network load, which in turn is going to reduce the latency. And that can be achieved by using web application acceleration compression. So all in all, we can speed up the traffic on our layer 7 HTTP load balancer by applying a combination of caching and compression. And as I discussed in the whiteboarding, when you create a web application acceleration policy, you have the option to include caching or caching and compression. So this marks the end of this lesson. Thanks for your time. Hello and welcome to this lesson on web application acceleration concepts. So let me first explain you what is caching and what is compression. Let's say you have a load balancer. So basically this is a layer 7 load balancer. And then there are different backend servers. Here we have 3 backend servers. There is an application user who sends the request to the load balancer, and then the load balancer is going to distribute it to the backend instances in the backend pool, and then it is basically going to serve the request from the application user. Let me explain you in layman language. Let's say the load balancer sends the request to the backend server, and when there is a response from the backend server that we want to serve to the application user, if we enable web application acceleration, then the load balancer is going to cache some data. And why does it need to cache the data? Because of 2 reasons. The first reason is when the further requests are going to be served from the load balancer, it would typically mean that the load on the backend server is reduced. The second reason why we should use caching is that the latency is also going to be reduced. Why? Because this time the request will be served from load balancer and not the backend servers. So 2 main reasons why enabling caching helps in case of load balancer. So that was about caching. Now let's talk about compression. So let me redraw this architecture. So there is a load balancer. There are 3 servers, 1, 2, and 3. And then there is an application user. So compression basically means that the backend server responses, they are going to be compressed before we return them to the web application user. So basically there are again 2 advantages. The first advantage is it is going to reduce the amount of bandwidth that is required. And secondly, the speed is going to go up. And I'm talking about the speed of the server's response over the network because we are compressing the backend server responses. Now, in terms of compression, please keep in mind that currently only the gzip compression algorithm is supported by web application acceleration. So this was about caching and compression. Now let's move on to some concepts. The first concept is with respect to acceleration. So what is an acceleration? The name of the service is Web Application Acceleration. As I mentioned in the previous whiteboarding, that while working with Web Application Acceleration, you create a policy and then you bind that policy to a load balancer. We bind this policy to load balancer through this acceleration. So when we are going to attach an acceleration to a web application acceleration policy, basically we are assigning a load balancer to that policy, and whatever we defined in this policy, whether we would like to use compression or caching, will ultimately be applied to the load balancer's operation. So that is your acceleration. We talked about caching. What's the benefit of caching in the previous whiteboarding? It basically reduces latency and then it also reduces the load on the backend servers. Now there is a concept of cache purge. Now what is this option? Let's say this is a load balancer and there are backend instances 1, 2, 3, and this is an application user. So let's say this user requests something which is being served by the server 1, and the subsequent requests are going to be served from this cache in the load balancer. By cache purge, we mean that this data that is going to be purged out. That means after purging out the cache, the request will then be served by the backend servers rather than the load balancer, because we have purged out the cache. Purging basically means we have removed the cache. And keep in mind, this cache purge, it is usually an irreversible action. So once you perform the cache purge, you cannot restore the cache. Now let's talk about considerations when it comes to caching and compression. So keep in mind that only the responses that return HTTP status code 200 is going to be cached. So caching and compression occurs only for HTTP status code 200. So caching and compression occurs for HTTP status code 200 response to a GET and a HEAD request. Few minutes back, I talked about cache purge, right? So what is going to be the maximum size of cache? Let's say this is the cache. It can be at max 100 MB. Now, when this size is reached, let's say you reach 100 MB for the cache, then this particular service, Web Application Acceleration, it is going to remove those resources from the cache. Let's say this is the cache and there are different resources. So it is then going to purge out or remove those resources from the cache that have been accessed the fewest times. So just to simplify it, it will retain the resources or the data that have been accessed frequently because it has to honor this maximum size. And then by default, the response that is going to be cached for 10 minutes. There are several options by which you can configure this cache time. Now there are few guidelines when you are configuring the cache time. Let's say your content is static, and in the second scenario, let's say your content changes often. So if the content is static, then cache can be configured for an extended period of time. And if the content changes often, then you need to configure the cache for a shorter period of time. So these are some things that you need to understand. So let's move on to the deck and look at web application acceleration concepts. As I mentioned, it works only with layer 7 load balancer, and only head and get requests are going to be cached, and only the responses that return HTTP status code 200 are going to be cached. So this point basically highlights that the backend content can change while the cached content might be outdated. So this also points to the fact why we need to sometimes manually perform cache purging, because the content on the backend might not be the same as the cached content. So in that scenario, we would want to flush or purge the cache. Until the cached content is expired or you perform a manual cache purge, the content is going to be available even if the file is removed from the backend server. And as I already mentioned, the maximum size of the cache can be 100 MBs. And if the backend server responses return the set cookie header, then they are not going to be cached. And then Oracle recommends that you do not cache the dynamic pages, because even if they are publicly accessible or protected behind the authentication, they might include some secrets like OAuth state parameters, and that might have dire consequences if they are stolen. So basically it can leak information. So this is basically a screenshot that is going to show you two things. So on the top, you see the baseline. So basically there are three parameters: client without web application acceleration, what is going to be the bytes received. Then the second parameter is load balancer without web application acceleration, bytes sent. And then backend without web application acceleration, bytes sent. Now the first parameter is client without web application acceleration. Because we have enabled compression in web application acceleration policy, therefore the bytes that are going to be received by the client gets a gradual decrease. Because we are enabling compression as a part of web application acceleration policy, hence the data that is received by the client is in compressed format, and hence the bytes received is going to decrease. When it comes to the second parameter, because we have implemented compression, hence the bytes sent with respect to the load balancer also gets a reduction. And then the third parameter is with respect to backend bytes sent. This also gets a very drastic reduction. Why? Because we have enabled caching. So most of the requests are going to be served from the cache in the load balancer, and the backend need not send the data every time. And hence you see that the bytes sent with respect to the backend after enabling web application acceleration also reduces. So you see that the compression is enabled, and hence we see a dip in these two parameters. And this is because of the caching. So this marks the end of this lesson. Thanks for your time. Welcome to this demonstration on web application acceleration. Let's get started. I'll take you to the OCI console, where you can see that there are two instances that are running in a private subnet. So they don't have a public IP address, and they are behind this load balancer, which has a public IP address. So it's a public load balancer. And if I try to access the IP address, you can see that it is pointing to instance 2. If I refresh it, it's going back to instance 1 and again 2, 1. Okay. So we have configured a load balancer. Now, if I go inside the load balancer, currently there is nothing set in the acceleration. So it is not associated with web application acceleration. So let me take you to the OCI console one more time. Click on navigation menu, click on networking, and under networking, you see that the third option is web application acceleration. So I'll click on this option. So let me create a web application acceleration policy. I'm okay with this name. I'm okay with the compartment. Now you see that there are two options. So it can be just caching. If you don't need compression, that option is there. And the second option is both caching and compression. Now, if I don't need caching, then I cannot select compression. So I can have either caching or both caching and compression. So I'll create the web application acceleration policy. Okay, so you see that this web application acceleration policy is now active. So if I go inside this policy, there's also a note here that the policy won't take effect unless it has an acceleration and caching or compression is enabled. So we have already enabled caching and compression. You see the caching is enabled and the compression is also enabled. So the only thing that we need to do now is we need to create an acceleration. So let me do that. Create accelerations. I'll select the compartment very quickly. And inside this compartment, I'll select the load balancer that's already created. And you also have the option to create additional acceleration if you have got more than one load balancers. Click on create acceleration. You see that currently it is getting created. So if I click here, you see that it is creating. So you see that this acceleration is now created and the attachment type is load balancer, and we have attached it to this particular load balancer. So if I refresh this now, so I will be able to see the acceleration. So I'll return back here and let me enable the log. So let me enable it. I'm okay with this log group and the log name. Click on enable log. So it is currently getting created. In the meantime, I'll try to access it a couple of times. Okay. So let me go to the log. So this is my log. I'll wait for the events to get populated here. So now you see that we have few log events, and if you just look at the response, the cache status is a hit. So it can either be a hit or a miss. So if it's a hit, then the request is being served from the cache. There are also details with respect to the compression. If I click on the request, the cache key is this, and you can see the format over here. So this is how you can basically know that the web application acceleration policy that you have created is actually working. So this marks the end of this demonstration. Thanks for your time.
Welcome to this module on DNS management. We'll first start the discussion on DNS service components, things like name servers, zones. I'll talk about the two different types of name servers, authoritative and non-authoritative, which is also known as recursive name server. I'll also talk about the process of DNS delegation, and then we'll talk about the two different types of zones that are available in OCI. Public DNS zone and private DNS zone. We also have demos demonstrating each one of them. Towards the end of this module, we'll talk about the different types of traffic management steering policies, things like failover, etc. So let's begin.